So finding the correlation coefficient between these two sets of data is pretty easy. All we do is put an equal sign, type correl for correlate, open the parentheses, and then select our two sets of data. Now in this question, maybe there was some confusion about what the two sets of data are. We're not really concerned with the years, but rather we're trying to compare the carbon dioxide and the hurricanes. So we grab first the carbon dioxide, and it actually doesn't matter which order you do it in, and then the hurricanes, and then close the parentheses and hit enter. It's super important to understand the difference between correlation and causality. And if you didn't get the correct answer on the last problem, let me explain what came out of this. So we found out that there was a relatively high, almost 0.7, was the correlation coefficient between carbon dioxide and the amount of hurricanes that are happening. And so basically all we can say about that is that there's some relationship, that increases in carbon dioxide and increases in hurricanes tend to occur, or historically at least have occurred in corresponding ways. However, we cannot say that it is in fact carbon dioxide which is the cause of the increases in hurricanes. That statistics doesn't give us enough power to prove something like that. So for example, and let me explain the difference. Correlation changes, for correlation, changes in one variable correspond to changes in the other variable. Okay, we can say that they correspond. For causation, changes in one variable cause the changes in the other. And let me explain the difference using this example. Okay, so you see the sunrise here and you see alarm clocks. The time at which most alarm clocks go off and the time at which the sun rises, there's a correlation between those two things. Okay, they seem to be very similar. Okay, however, it is not a cause that the sunrise does not cause the alarm clock to go off. The alarm clock goes off because of the user who sets the alarm clock to go off at that time. Okay, and similarly, just because the alarm clock is going off does not mean, it does not cause the sun to rise. So there can be relationships between variables, but they might not be causal. So it's important in this case for us to realize that, yes, increases in CO2 and increases in hurricanes are patterned in the same way. However, this does not prove that those two things are causally linked. It does not prove that increases in CO2 are causing more hurricanes. All right, so good. You've figured out how to find the correlation coefficient. Now we're going to move on to talk about averages, another important statistical tool. All right, so we're back in Excel, and we're going to look at some examples of how to calculate the average of a set of numbers. It's really, really easy to do this in Excel. Of course, the average gives us the mean value, the expected value for a set of numbers, the number that's right in the middle. And to do this in Excel, it's very similar to the correlation coefficient, except it's a little bit easier. We just click in, we hit equals, and then we say average, and then we open a parentheses, just like we did with correl for correlate, but this time we just type all of average. And then we just select the set of numbers we want to take the average of, and then we close the parentheses just like that. And that's it. So in this example here, I've got the number of years since they started having detention. This is at a school, a made-up school. They've had detention at this school from 96 to 2007, and then they have the number of incident reports that were given out at the school from 96 to 2007. And you can see the average number that was given out each year is 205 incident reports. Which is good. All you have to do is say equals average, and then select the data you want to take an average of, and then close your parentheses. It's that simple. Okay, so that's good. So this is the overall average, just labeling the data. Now, if I wanted to also know, so let's say also this school in 2001, right, they made detention 30 minutes longer, thinking that, kids really wouldn't want to sit through an extra 30 minutes of detention. And they want to know, well, what's the average number of incident reports before that change was made and the average number after. So you don't have to select the whole column when you take it. So this is average before the 30-minute addition, and this will be the average after the 30-minute addition. So from the years 96 to 2000, detention was 30 minutes shorter. So before that 30-minute extension, we can find the average, just like I did before. You type equal sign and then the word average, open a parentheses, and select the data you're interested in. In this case, we're interested from 96 to 2000 before they added the 30 minutes. And in that case, the average was 282. And in this case, we want for after they added the 30 minutes. So we say again, equal sign, average, open a parentheses, select the data, and close it. And you can see in this case, the average was 150. And so this is really interesting. It tells us, okay, well, on average, over the past 11 years or so, the overall average incident reports at this school was 205. It was much higher, 282, before they extended detention. And once they extended detention, the average was much, much lower at 150. All right, so let's try this, practice this out on our own. So download the second Excel sheet, which is what you're going to do in a second. And it tells you the number of car crashes that happened in Cambridge each month from 2000 to now. And again, I've made this data up. It's not real. What I want you to find out is the average number of cars that got in an accident in each January, okay, and also the average number of cars that get in an accident per month since 2000. Just find the overall average. All right, see if you can do that, and then we'll all be done. All right, so let's see how we can calculate the average for the number of car crashes in January with all this data. So the first thing to see is that there's several different, here's one, and if we scroll down, here's the next. There are many Januaries, right? We go all the way from 2000 to 2010, so there's a lot of Januaries. Here's the next one. So we need to get all the numbers for January in order to get the average for January. So we hit equals because we're doing a formula, and average is what we type because we're looking for an average. We open the parentheses, and now the way we've normally been finding averages is by clicking and dragging and selecting a bunch of data, which would work fine, except that in this case our data is separate, right? It's a bunch of different boxes for just January. And so I have choice. I can click on the first one and then press comma, and then click on the second one and then press comma, and then go all the way down the list and get the next one. Where's the next one? Right there. And then hit a comma. I can do it like that, or I could click all of these individually while holding the control button, which would be another option. But in either case, if I go through all the different Januaries, where's the next one? It's going to take me a second. Let's see, January 5 and January 6. There it is. And January 7 and January 8 and January 9. Sorry, this is taking a while now. You can fast forward if you'd like. And January 2010. If I close the parentheses and hit enter, I should get the average, which is around 252 accidents each time. All right, now if I want to find the overall average accidents as opposed to those just in January, I can hit the equal sign, and this time it's going to be a little bit easier. I type the full word average and open a parentheses, and this time I'm going to grab all the data. I won't have to go through each of the individual Januaries, so I can click and drag over all of it, close the parentheses, and hit enter. And we can see that the average overall, or accidents, all months, is around 175. So the question is, why are these two numbers so different? Why is the average accidents in January so high and the average accidents in general much lower? And this is an important point about statistics. Statistics will help us to see patterns in the data, to see information that's hidden in the numbers. But when it comes to making sense of that information, it still relies on your brain and some thinking. So why do you think there might be more car accidents in January here in Cambridge? Well, there's a lot more snow on the ground, and it's a lot harder to drive when there's snow on the ground. People get in a lot more accidents when it's snowy than they do in general, which is why there's so many more accidents in the winter months. All right, so that does it for this. We've learned how to calculate the correlation coefficient and interpret its meaning. And we've also learned how to use Excel to find the average of a set of numbers. And these are going to be really valuable tools for you as you're using Excel in your own original research, in analyzing a data set, or anything like that.